So now we're looking at how to solve systems of inequalities by graphing. Unlike when we normally solve for something, in this case, the solution is actually on the graph. Any value in a certain area that we end up with on the graph is going to be a particular solution, but we're looking at the most general sense of a solution in the sense that anything in this area that we find is a solution. In most cases, there are infinitely many solutions. They just have to be in this area that we find. So our first step is let's look at our first inequality. Y is less than 3x plus 2. So what we want to do is we want to graph y equals 3x plus 2. And because the inequality does not include the equal sign, it's strictly less than, it's non-inclusive, that means it doesn't have the equals, our line is going to end up being a dashed line, and that's because anything on the line itself is not going to satisfy this inequality. So if we graph y equals 3x plus 2, well, we can tell right off the bat that has a y-intercept of 0, 2, so we'll go ahead and graph that point. I'll go ahead and put a scale here too. Typically, if there's not a scale given, we assume that it's each square represents 1 by 1, a 1 by 1 unit. But I will go ahead and provide a scale. Now let's look at what could we put for another point to graph this this line, y equals 3x plus 2. Let's use 1. 3 times 1 is 3, plus 2 is 5, so we'll be at 1, 5. So 1, 1, 2, 3, 4, 5. So we know there's another point here. And just for good measure, let's go ahead and determine another point. Let's use negative 1. So 3 times negative 1 is negative 3, plus 2 is negative 1. So we'll be at negative 1, negative 1. And then we'll go ahead and we will graph the line through those points, remembering again, it's going to be a dashed line. So here's our dashed line for our first line, for our first inequality. Now we're going to test a point, because we know we're either going to need to shade the right-hand side or the left-hand side of this line. So let's test the point 0, 0, because that always makes it easy, and we know it's definitively on the right-hand side of this line, or below it. This one's closer to vertical, so it's hard to tell if we mean right or below, but either one means the same thing. So let's test the point 0, 0. Is 0 less than 3 times 0 plus 2? So is 0 less than 2? It is. So we know we want to shade the right-hand side of this. So let's go ahead and I'll use another color to shade on this side. Let's go ahead and use blue. So we're graphing this inequality first. And we know we want to shade the right side because that's the side that 0, 0 is on, and it makes the inequality true. So there's our first inequality. And now we're going to graph the other side, or the other inequality in our system of inequalities. And that is y is greater than negative x minus 1. So again, we graph the line y equals negative x minus 1. And in this case, again, it's going to be a dashed line because it's a non-inclusive inequality. The equal sign is not included. So we plot a point. I'm going to go ahead and change the colors again so we can differentiate. So we plot the point. Let's go with, let's put in 0. So negative 0 minus 1. That's just 0 minus 1, which is negative 1. So 0, negative 1 is one of the points. We'll go ahead and use... Let's go ahead and use 2. So negative 2 minus 1 is negative 3. So 2, negative 3. 1, 2, 1, 2, 3. And let's go ahead and go with negative 2. So negative negative 2, that's 2 minus 1 is 1. So negative 2, 1. And then again, we will connect the dots to draw our line, remembering that, again, it's a dashed line. And the reason for that is because it's a non-inclusive inequality. No equal sign is included. So there is our line for our second inequality. Y is greater than negative x minus 1. Excuse me. And now we go ahead and we test another point. In this case, I'll use 0, 0 again, because that's definitely above the line. 0, 0 for that is 0 greater than negative 0 minus 1. So is 0 greater than negative 1? 0 is greater than negative 1. That checks. So we know we want to shade above this line. So we'll go ahead and I'll pick another color to shade above this line. So now we're graphing this inequality on the same graph as the other line, and then the other inequality. And now the solution to this, if we can tell, is where the two regions intersect. So it would be this section over here. So I'll go ahead and select, let's go with purple again. And since this is our final solution, I don't need it to be transparent at all, so I'm going to go ahead and color this in a little bit more solidly. So our solution to this system of inequalities would be any value inside this region over here. So if we test any point in there, and I guess that is one reason to make it transparent. So I'll go ahead and switch back to our more pixelated spray paint to shade this in. As long as it's apparent, that's all that matters. The section that is the actual solution. And then how do we test whether or not this is right? How do we know whether or not this is the correct solution, the shaded region over here? Well, we can check by testing a point inside this area. So let's go ahead and 3, 0 is inside this shaded area. So let's test the point 3, 0 in both inequalities. So 0 less than 3 times 3 plus 2. 0 is less than 11, so it checks in our first inequality. And in our second inequality, 0 greater than negative 3 minus 1, so is 0 greater than negative 4. And it is, so it checks in both of our inequalities. And that means that the shaded region, not including the boundary lines, that I've shaded in purple here, is the solution to the system of inequalities y is less than 3x plus 2 and y is greater than negative x minus 1.